These are the Module 11 Part 3 notes. We are now going to switch from binomial distribution to something we are going to use a whole lot more, which is the normal distribution. And so you've seen this normal curve before. Okay? So we have, let's change so the colors match. We have talked about creating a normal distribution. Here we have got a mean of 100. That one's right here. We have a standard deviation of 15. So again, plus 1 standard deviation, plus 2 standard deviations, plus 3. So plus 15, plus 15, plus 15. And then subtracting the other direction, minus 1 standard deviation, minus 2 standard deviations, and minus 3. You notice we're looking at the raw scores here. So we've got an IQ mean of 100, 1 standard deviation above the mean is 115, 1 standard deviation below the mean is 85, and we've talked about what that means before. We used the empirical rule to discuss how much of our population is trapped between 1 standard deviation above and below, or 2, right? So just a quick reminder of what our empirical rule told us. And that's that 68, 95, 99.7. And that's great if we are trying to approximate and we have values that or we are looking for values that are 1 standard deviation above and below. Okay? It doesn't always work that way. So we also have something called a z-score. So our z-scores are labeled below here. Our mean is got a z-score of 0, so it's hard to figure anything out from that. But our 115 has a z-score of 1. Notice that was 1 standard deviation above the mean. Our 130, which we found by adding the standard deviation to the mean twice, has a z-score of 2. And that 145 has a z-score of 3. It is 3 standard deviations above the mean. Okay, so a z-score and I'm going to use counts instead of shows. Counts how far a raw score is from the mean. And I think this sentence was going to be grammatically incorrect, so I'm going to fix this. Counts in standard deviations. Okay, now we're not so lucky that everything is a whole standard deviation above or below a mean. So let us go down here. We have got our raw scores. This is a normal distribution. Our notation is just going to be an n for normal. And then it's going to list the mean and the standard deviation. Underneath, this is a z distribution. And when we are talking about a z distribution, sometimes you'll be told it's standardized or normalized. Our notation for our z distribution is n, 0, 1. So we have a mean of 0 and a standard deviation of 1. That aligns with what we have above in our normal distribution. Okay, so notice how these are lined up. That mean is 100. My standard deviation is 15. If I have it written this way, n parentheses 0, 1, I know it has been standardized. Okay. So a z-score, and so let's highlight this one more time, tells you how far away from the mean a data value is in terms of the standard deviation. So we are counting standard deviations. 1, 2, 2.1, 2.15. It gives us a way to place something on our curve without it having to fall at exactly 1 or -1 standard deviations.